Okay, so we'll start at the beginning. I gave you some review here. Again, if you have access to the actual PDF document, let me just scroll through it for you. And we're at the beginning. And so, you know, I'm going to say that we're going to do the exercise 1 now. And what I mean by that, it's the materials for exercise 1. And the materials for exercise 1 is you're actually covering 3 separate chapters of Wells' text, which is chapter 1, chapter 2, and chapter 3. My intent is not to read that to you. We would love for you to read that. However, you may be at the point where you're saying, I think I'm ready to do the examples and that basic algebra stuff. Nothing wrong with that, all right? So what I'm going to do is I'm going to click on the examples, and let me do that now. And it brought me right to the example. I just clicked on it, all right? So what I'm going to do is start working the examples. As I do it, you know, initially when I start, it might seem like I'm spending an awful lot of time on what I'm saying over here, but they want me to add, and I want to point out what they're asking me to add. They're asking me to add a bunch of terms together. Now, this first term has a factor of 3 in it and a factor of a minus b in it. The second term has a factor of minus 2 and a factor of a minus b. So forth and so on. Third term, a factor of 6 and a factor of a minus b. And the fourth term has a factor of minus 4 and a factor of a minus b. Now, what do I notice about those terms? Those terms are like terms. What does that mean? They have an identical variable part, and that variable part is a minus b. So what I do, I just add their numerical coefficients together. Let me write that down for you. 3 plus minus 2, and these are the numerical coefficients, 6 plus minus 4. And what are those terms? Those terms have a variable part, a minus b. Let's do the work. 3 minus 2 is 1. 1 plus 6 is 7. And 7 minus 4 is 3. So what do I get? I get 3 times a minus b. Again, I'm going to say that's an answer, but I'm going to simplify it. And that would give me 3a. I'm using distributive property multiplication minus 3b. Look at their key, and they have both answers listed for you. They have this answer and that answer. Look at the next one. And I want to point out this is an expression over here. This expression has 2 terms in it. They want me to add it to this expression, which has 3 terms in it. And they want me to add to this expression, which has 3 terms in it. The way I'm going to do it is just go left to right through the problem. And I'm going to just, look at things. So I'm looking at 6a. Is there another term with a in it? Yeah, this one over here. And then this one over here. And what would I do? I'm going to add their coefficients. Right, so 6, because they asked me to sum it or add it together. 6 minus 2 is 4, and the coefficient of that last guy is minus 1. So 6 minus 2 is 4, 4 minus 1 is 3. So I'm going to say 3a. All right, I'm going to the next term I'm looking at, which are x squareds. All right, and I'm going to look around for x squareds, and I'm seeing a bunch of them. And what I'm going to do, I'm going to add their coefficients together. So minus 7 plus 3 is minus 4, and minus 4 plus 2 is going to be minus 2. I'll write that down for you. All right, let's keep looking through it. And next thing I'm looking at, and again, when I'm pointing out what I'm looking at, gee, what am I looking at? I'm looking at this cube, y cubed term right over here. Whoops, sorry about that. My eraser, I didn't mean to scratch that. I want to highlight it. So we're looking at the cubes. I see no other cubes. So if there's another cube, just that's it, just 3y cubed. Is there anything that I have not accounted for? Yeah, I'm looking at minus mn. I'm going to put a circle on this indicating I've added those 3 algebraic expressions together, and that's what I got. Let's look at their answer. Now, you may wonder why they put it in a different order. And I'm starting to reason, it looks like they're trying to put it in some kind of alphabetical order. All right? And again, you may disagree with it, but it doesn't matter. It's a different order. But I do see 3a. I see the minus 2x squared. I see the 3y cubed minus mn. Not bad. We got that over here. All right? Let's do the next one. Again, it's an addition problem. And I'm going to point out this is 1, 2, 3, 4 terms. That's an algebraic expression. This is 4 terms. And this is 4 terms. And what are they doing? They want to add it together. So I'm going to look at it, one thing at a time. The first thing I see is 4. Whoops, sorry, but I did that again. I really apologize. I got 4x here. Or is there another x? I'm looking around here. And then another x right over there, right? So I'm going to combine their coefficients. and 4 minus 15 is minus 11, and minus 11 plus 10 is minus 1. Let me write that down for you. Now minus 1x. Now someone says, why don't you put a 1 there? You could. I'm not saying it's wrong, but minus x. All right? Now let's go to the next guy. And go look at squares, x squareds. I see one here, I see one here, and I see one over here. So minus 3 plus 12 is 9, and 9 minus 9 is 0. All right, now if you want to write that down, you can. I'll put it down for you, but I don't think it's important. There's 0x squared, because there's nothing, it's not there. All right, what's my next term? Let's take a look at it. I'm going to say there's a constant, and a constant here, and a constant here. And let's add that together. Minus 11 minus 7 is minus 18, and minus 18 plus 4 is minus 4. All right, I'm going to go to the cubes now. And let me just put that down for you. Let's see. I'm going to go for cubes now. I see a cube here. That's plus 5 of them. I see a cube here, and I see a cube here. I think I've counted for everything, right? So let's see, 5 minus 8 is minus 3, and minus 3 plus 6 is going to be plus 3. I'm going to put this in an order, and I'm going to put in descending order of the exponent on the x. So x cubed minus x minus 4. Now you're going to be surprised you make mistakes sometimes. 3x cubed minus x minus 4. Feel good about that. Let's go to number 4. Again, I'm getting a little more comfortable with this, and what I mean by that, maybe I should stop using a highlighter now and just sort of like check this out here. And this is an algebraic expression with 2 terms in it. This is an algebraic expression with 2 terms in it. And this is an algebraic expression with 2 terms in it. What I'm going to be doing is looking around for like terms. And let me talk about that. So I'm looking around for the terms that have a plus b in it. Right? And I see one over here. Right? And yeah, certainly sometimes you need a highlighter too. It's not really. But I'm going to look for terms with b plus c in it. Whoops, sorry about it. It's a different color. Sorry about that. B plus C, B plus C. And then I'm going to look for the terms with C plus A in it. And let's get busy. So the first thing I see is the A plus B term, and that's 9 minus 5 is 4. And they're A plus B. I'll check them off for you. Next, I'm going to look at B plus C. What's minus 8 minus 3 is minus 11, right? That's B plus C. And then I'm going to look for the terms with C plus A in it, and that's going to be minus 3. And I did what they said. They said add them together, and I did that. All right, I just did it. Now, I'm going to say there's probably something else you could do, and I'm going to try to simplify it a little bit by using the distributive property. All right? Before I do that, though, I want to point out, if you look at the K, that's there. You got the 4A plus B minus 11B plus C, and minus 3C plus A. I'm going to use the distributive property now to write this down a little differently. All right, let's put that down for you. And what's that going to look like? 4A plus 4B minus 11B minus 11C minus 3C minus 3A. Put a line there, add together. What do you get? A. Let's see, that would give you what? Minus 7, right? Minus 14. And that's looking at right there. Not bad. You got that done too. Let's go to the next one. For some students, this is more complicated because it's a fractional problem. But, I'm going to say I'm getting a little better at this, but the fraction might cause some trouble. So I'm looking at the A's. I'm going to add these 2 algebraic expressions together. I'm basically doing term by term. I'm going to look at the B. And I guess I'll look at the C. And then write this down for you, all right? So I'm going to do the A first. I like to go in alphabetical order. That's 3/4 plus 1/6 of an A. I realize some students might argue now that they don't want to write that down. We're not saying you need to write it down. I'm just saying that's what I'm seeing. The next thing is 2/5. and minus 4/3, and that's the b guys, right? And then plus, let's write this down, minus 1/3 plus 5/7 of a c. I'm going to do the arithmetic now for you. And the arithmetic is just adding fractions together. So the first term, which is really the term with the variable part a in it, I'm going to add it together. And I'm going to say that the LCD between 4 and 6 is 12. And then what do you get? Well, what times 4 gives you 12? That would be 3. And 3 times 3 is 9. Plus, what times 6 is 12? 2. 2 times 6 is 12, and 2 times 1 is 2. All right, let's go to the next term, and I'll do that later. Plus, what's the LCD there? 15. And this is b. What goes in the numerator? Well, let's see. What times 5 would be 15? 3. And 3 times 2 is 6. Minus, what times 3 is 15 is 5. And 5 times 4 is 20. Let's keep going. The LCD between 3 and 7 is 21. Let's see. 7 times 3 is 21, so I got minus 7. And 3 times 7 is 21, so 3 times 5 is 15. 9 plus 2 is 11, so it's 11/12 of an a. Then you can get minus, because 6 minus 20 is minus 14. 15ths of a b. And then what do you get there? Looks like 8/21. And there's c's. I'll put a box on it, and that's when I'm going to look at the answer key. I see the 11/12 of an a, minus 14/15ths of a b, and 8/21 of a c. It's working out pretty nice. Let's do the next one. And I'm kind of looking at it. Man, it might look a little disturbing to you because there's a lot of letters in it. So let's take a look. And I'm going to look around for terms that have a, b squared in it. Right? I see one over here. No, you don't need to use a highlighter to do that. I'm going to look for terms that have a squared b in it. I'm seeing that right over here. And I'm going to look for a term, well, there's no other terms with b cubed in it, right? And there's no other terms with a cubed in it. So let me write those down first. So I'm going to write down 8b cubed. I forgot to read a word, and that's important. So I'm going to write that down now. All right? And this is really important. And I want to tell you what happens to a lot of students. What happens to them is they're so used to seeing them saying add, 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 but now they're saying subtract. See that? So what I'm going to do is I'm going to highlight the word for you. I'm going to highlight this word here. I'm going to write it down now. Let's put that down for you. So someone says, how do you subtract from? Well, I'm going to subtract from 5a cubed minus 2a squared b. Whoops. A little fast there, didn't I? Sorry about that. Plus 4ab squared. And I'm going to subtract from that this. Let's write this down. This is 5a cubed minus 2a squared b plus 4ab squared. Now I'm going to subtract each of those terms now. So you can get minus 7ab squared. Minus of minus is plus. That's plus 9a squared b. And then minus 8b cubed. All right, I'm going to tell you something that Wells is always saying. He's saying, do things by inspection. Don't do too much writing. And I kind of agree with him there. The more writing you do, the more likely you're going to make an error in the copy. But I'm going to still go through this. Right, the way I'm going to do it is I'm going to look for terms that are like each other. So I'm going to say the a squared b. Let me do it over here. Do I see any other terms with a squared b in it? I do, right over here. All right. Let me do another one. And I'm going to look for the ab squared. Whoops, let's go to red. I'm looking for ab squared. Wow, this is really convenient, isn't it? Well, let's write this down now. What do I say? I see 5a cubed, that's this guy over here, minus 8b cubed. Now let's combine the other terms. Let's do the yellow guy first. That's minus 2 plus 9 is plus 7, a squared b, and 4 minus 7 is minus 3, and that's ab squared. I'm going to circle it, and I'm not going to say I'm right until I check it. So I'm seeing the 5a cubed, I'm seeing the minus 8b cubed, I'm seeing the 7a squared b minus 3ab squared. So it worked out fine. And again, don't worry so much about the order. Certainly when I rewrite things, you may wonder why I do that. It just looks neater to me, and I wrote it really in descending powers of a. That's what I did, like a cubed, a squared, a, and then no a's. All right, let's do the next one. Next one says subtract the sum of these two from this thing. I'll write that down for you. I'm getting a little better at this now. So it's 6a cubed minus 7x minus 4, and I'm going to subtract the sum of these two guys over here. So I think I can write the sum down. I'm looking at it, and I'm getting a little better. The seventh problem, I'm going to say that's x cubed. There are no other x cubes in that addition problem. Let's do the x squareds. That would be, minus 1 plus 9, which is plus 8, x squareds. And then, minus 8 plus x. That's going to be minus 7, right? Is there anything missing? Yeah, plus 5. All right. So I'm going to see if I can do it without, a lot of writing, right? So I'm going to say 6x cubed minus x cubed is 5x cubed. I think oh no, I didn't. I'm sorry. So minus 7x minus a minus 7x, there's no x's. I'll write that down for you. And then I got minus 4 minus 5, which is minus 9. Is there anybody missing? Yeah, I didn't take care of the square term. That's minus 8x squared. I just don't like the way that looks. I'm going to rewrite it in order. That would be 5x cubed minus 8x squared. There's no x's. I'm not going to put that down. Minus 9. Now, I make mistakes, and you're going to make mistakes. Please look at the key. I'm feeling good about that. Let's go to the next one. The next one, you notice there's a footnote. We do recommend you read. In the footnote, they talk about this symbol that a lot of students have not seen before. They've not seen this before. Right? It's a horizontal line above that. And they go through a little story for it. So I'm going to just tell you that it's a grouping symbol. So if I were to write that down, I'll tell you what that means. If I see this over here, I would interpret that as this. That's how I interpret it. So what I want to do is I want to write that down for you. This is 4x minus 3x, that's a grouping symbol, plus minus 2x, and I'm going to interpret that symbol now and remove it. So what did you get? You would get minus x, and minus a is going to be plus a. Let me keep moving. 4x minus, we're still doing the group. This is 3x plus minus 2x minus x is minus 3x plus a. Again, Wells is always saying you really try to do as much as you possibly can in your head. And you notice I'm doing a lot of writing. I'm just saying what's going on in my head. This would be 3x minus 3x plus a. What do you get over here? 4x minus, I'm still working inside the group, 3x minus 3x, no x's, but you do get an a. And what do you get over in the end? 4x minus a. All right, doing all right. This one over says enclose the last three term of this expression. I'll write this down for you. And you want to enclose the last three terms in the expression in a parentheses preceded by a minus sign. All right? Now someone says, why would they ask you to do that? We do that a lot. We actually rewrite things and we parenthesize them. But let's write down what they said to do. And I'll write that over here. A minus B minus the last three terms in parentheses. But notice there's a footnote over there, and I'll read it to you. It says the intent here is to rewrite the expression without changing its meaning. I do not want to change its meaning. So what I'm going to do, I'm going to say it would be minus C, because minus minus C is plus C. It would be plus D, because minus plus D is minus D, and then minus A. And I'm going to say that's my answer. That answer is listed over here. That's what that's going to do. Someone would say, what's this thing over here? This is me checking to see if I got it right. Let me write that down for you. This is A minus B, minus a minus C is plus C, minus plus D is minus D, and minus minus C is plus A. Is that what we have up here? Well, let's take a look. We got A minus B plus C minus D plus A is working out fine. All right, so let me just point out what you have to do now. Certainly hope you read the section. Hopefully you've done the examples, you understand the examples. And now it's time to get busy with the work. Now, certainly our gut feeling here is that if you are understanding what's been presented to you, that you should be able to do these problems really kind of, easily. So when I'm looking at these problems over here, again, I want to emphasize to you, there's an instruction. You read that. You know what you have to do. You have to add that stuff together. Now, when I say that stuff together, there's 1, 2, 3, 4, 5, 6. 6 algebraic expressions that you have to add together. We've done that before. What do they do over here? They give you an answer, and they do provide some work for you. Now, you may look at the work and say it's not needed. It's not needed then. Same thing here. They want me to add. They have an algebraic expression here with 3 terms in it, an algebraic expression with 2 terms, and another algebraic expression with 3 terms in it. They want you to add together, and they do give you an answer. So forth and so on. You're supposed to work through those problems. I know it's difficult, but the more time and effort you put into this, the easier it becomes. Now, someone says, oh, it's too many problems. I can't get through them all. You can get through them all, one step at a time, including you have to take a break and come back to it later. You get through those, all right? Just a brief thing about the Sage Code. If you do have access to the internet, I would recommend you go to this website over here. I would either recommend, if you have a computer, to download it to your computer or use the interactive web-based application and play around with the software. You should learn how to use software. But more importantly, you should learn what Wells is presenting. Wells did not have access to a digital computer, but you may. And if you do, you may want to see how digital computers can actually deal with problems. All right? Now, if you looked at my preliminary videos, you notice I actually went through this one over here using Sage, both as an interactive web-based application and as an application on my computer. All right? So hopefully you've paid some attention to that exercise 1 and you're going to work through it. All right? I do want to again remind you that this material that we're presenting to you is made for the Prison Mathematics Project participants only. All right? Now, granted, you have access to the YouTube. That's fine. You can look at this stuff over here. You just don't have the PDFs. Again, for those students or teachers that need to reach out to me, my name is Ron Bannon. My email address is Bannon. That's B as in boy, the @ symbol, NNON, and I'm located in the United States. Thank you.